Question number 1 involves a rifle and a bullet separating by an internal force. This is going to be an explosion, which means that my initial momentum will equal 0, which has to also equal my final momentum. My final momentum is going to be a combination of momentum number 1 plus momentum number 2. That's going to be the momentum of the bullet and the momentum of the rifle itself. So 0 is going to be my total because of conservation. And so I end up with two products. These have to be opposites of each other to cancel out to 0. And so I have the mass of the bullet, which is 1 gram. 1 gram is 0.001 kilograms, which is the unit that I'm going to have to use. So I've got my mass times my velocity of 150, plus the mass of the rifle itself, which is 2, times the velocity, v2. So this right here is going to be 0.15. So I end up with 0.15 on this side. I'm going to subtract that over, and that's going to equal 2v2, which means my final velocity for the rifle is going to be a negative answer. It's going to be negative 0.075 meters per second. It's a negative because it's going to be moving in the opposite direction of my bullet originally. Question number 2 is the same question. However, the bullet is going to be, the rifle is going to be held up against the body of the shooter. Her mass is 48 kilograms plus the 2 kilograms of the rifle itself, which means instead of the 2 kilogram rifle moving backward, it's going to be the 50 kilogram bullet rifle person combo moving back. So I'm going to bring down this same equation. It's going to be 0 equals 0.001, the same mass of the bullet, same velocity of the bullet, only now it's going to be 50 times v2 instead of 2 times v2. When I do this, I'm going to have the same negative 0.15 over on this side. I'm going to have a 50 times v2 on this side, and my new velocity number 2 is going to be 0.003 in the negative direction, meters per second. You'll notice that by increasing our mass by quite a bit, we decrease our velocity by a lot, which is why you would hold a rifle up against your shoulder to reduce the recoil speed. Recoil speed is the speed at which something kicks back. Question number 3, train in a freight yard. It says that our first empty car is moving at 10. It says that the loaded car is stationary, so it is at rest. The loaded car is 3,000 when empty plus 12,000 kilograms of cargo, which means that my mass number 2 is going to be 15,000 kilograms because of the empty car plus the cargo inside. So this looks like a collision. Well, it doesn't matter what kind of a collision. I see that this is going to be an inelastic collision because the objects are going to hit and stick together. So my initial equals my final. So I see that my stationary car is going to have no momentum, which means that I'm going to have momentum of the original train car only, plus the two train cars are going to stick together, which means that I can show their masses as a sum total times the final velocity. So the mass of the original empty car is 3,000 times the original speed given to us as 10. The original empty car that was moving was 3,000. The stationary car, we've already decided, was 15,000. So I'll end up with 30,000 divided by 18,000, and the total velocity of the two while they are stuck together is going to be 1.7 meters per second. Much slower than the original 10 that we had because of the increase, the big increase in mass. Question number 4 involves an astronaut throwing away an empty tank. This is an explosion question, which means that before the astronaut throws away the tank, there is zero momentum between the two of them, and that's going to equal the final momentum afterward. So 0 is going to be equal to the combination of 1 plus 2. So just like my first question up front or at the top, I'm going to have two momentum values that are opposite in sign but equal in value. So 0 equals mass 1 v1 plus mass 2 v2. I'm given the mass and the speed of the oxygen tank. So I have a mass of 10 multiplied by 2. I have a mass of the astronaut as 80 times v2. 20 gets subtracted to the other side, and now I have negative 20 over 80, which will be negative 1/4. My velocity for the person is going to be negative 0.25 meters per second. It's negative because he's drifting off in the opposite direction. It's 0.25 because he's much heavier. His speed's going to be much slower. Tennis player returns a serve. I have a change in velocity given. Comes in going 30, leaves going 25. This question is giving me a time and asking about a force. This is not going to be a conservation of momentum question because I am looking at a single object by itself. First thing I want to look at is the change in velocity. Comes in going 30, leaves going 25. It doesn't matter which one gets assigned a sign, but they do have to be opposites. So if I like, I can say that it comes in going in the negative direction and then it leaves going in the positive direction. That means it comes in going to the left, it gets struck by the tennis racket and leaves going to the right. I'm not sure why I drew a circle there. So I have negative left 30, I've got positive right 25, which means if I did my change in velocity, which is final minus initial, I end up with positive 25 minus negative 30. Negatives cancel, and I end up with a change of positive 55 meters per second. It's a very big velocity change because I had to stop it and then start it in the other direction. So now I can do my impulse equals my change in momentum, my net force times my time is equal to my mass times my change in velocity. Calculate the net force. So my force is the unknown. My time is 1/2 seconds, 0.5. My mass is given as 0.2. My change in velocity I calculated as 55. I could have just as easily chosen opposite signs and had a negative 55, and that's fine. I'll end up with a negative force that way. My force and my change in momentum will end up being in the same direction. So question number 5, when I do 0.2 times 55, I get 11 divided by 1/2, and I find that my net force is going to be 22 newtons to make the tennis ball change its velocity by a value of 55. Number 6, we're looking at the initial momentum of car 1, the initial momentum of car 2. They're going to stick together to give me a total mass. And I want to find the speed of the two cars after the collision. This is a very basic conservation question. So I have two cars moving initially. So I'm going to have M1 V1 plus M2 V2. And that's going to equal the two of them stuck together afterward times V final. So if I put in my numbers, I have 8 1875 times 23. I have 1250 times 17. And I have the two masses added together times V final. A lot of numbers with some pretty basic math. Take the product, take the sum, add them up, divide. And so using some basic algebra, I get a final velocity for question number 6 of 20.6 meters per second. You'll notice that's a little faster than the slow car that got hit and a little slower than the faster car, which makes sense. They should have something in between. There's page number 1. Flipping over to the back. Two girls with two masses are on frictionless ice, and they're going to push away from each other. So what effect will the push on the larger, what is the effect of the push on the larger girl? These two girls are going to experience the same force, the same impulse, the same change in momentum. What is the impulse that each girl exerts on the other? If I can find the impulse of one, I find the impulse of both in the opposite direction. Speed change will be some math using change in momentum. So impulse equal to the net force times time. I'm not given force or time, but I do know that the impulse is also the change in momentum, which is m times delta v. These girls start at rest, which means final velocity is going to be the change. So smaller girl goes from 0 to 10, and she has a mass of 50. So I have a mass of 50 going from 0 to 10. So the impulse felt by her is going to be 500. The impulse of the 70 kilogram girl will be negative 500. The unit's going to be a Newton second. What is the speed of the larger girl? The larger girl is going to experience the same exact impulse. So if I write literally the same exact equation, put in my negative 500 because it's in the opposite direction, 70 times my change in velocity. Her change in velocity will be her final because she starts at rest. And her final velocity will be, for question number 7, 7.14 meters per second. It will be a negative because she is going in the opposite direction. Question number 8 involves an arrow coming in with all of the original momentum. It passes through. I see that the melon is going to have a shape change, so I'm going to assume a loss in kinetic energy, but that part can be done later. If I look at this as a conservation, because there is a collision between the arrow and the melon itself. So there's my final momentum. So I end up with mass number 1 times V1, that's the arrow. Mass number 1 times V final, that's after the arrow goes through the melon. And then I have mass 2 V2 for the melon itself. So I have the mass of the arrow given as 0.05. Its original speed was 30. Afterwards, also 0.05 mass, new velocity of 18, plus the mass of the melon is 2 times its velocity. Product, subtract it over and divide by 2. And our final velocity will be in the same direction. I'll get a positive velocity, and that velocity is going to be 0.3 meters per second. The melon flies off in the same direction as the arrow itself. Mike and Joey are going to crash into each other at a goal line, so I have two guys approaching each other. So will Mike score? So the question is, whose momentum is greater? Their greater momentum will continue forward. So I'm going to take my momentum of 1 and the momentum of 2. They are in opposite directions. One will be positive, one will be negative, and we'll figure out what it equals at the end. If it's a positive, Mike keeps going forward. If it's a negative, Joey drives him back. If it's 0, they stop dead at the 2-yard line. So m1v1, m2v2 equals question mark. So I have 100 times 9 going forward. I have 75 times negative 12 going backward. And when I do that, I find 900 minus 900. Nice simple number. I get a total momentum of 0. They cancel out. They hit and they drop where they are. Number 10, we have a ball traveling forward, colliding with another ball moving in the opposite direction at a speed of 12. So I'm going to call this one a positive, and I'm going to call this one a negative because they're in opposite directions. The 0.5, which was going in the positive direction, bounces backwards, so that's going to be a negative there. And I can calculate the speed of the second ball. So this is going to be another conservation question because I'm looking at a collision between two objects. So I have m1v1 plus m2v2 equals my first object has a final velocity, I'm going to call it v1 prime, plus mass number 2, velocity number 2 prime. Prime simply means final. So plug in some numbers here, so I get 0.5 mass times plus 6. I have a mass of 1 times a velocity of negative 12. I have my original mass of 0.5, now going backward, negative 14, plus my mass of 1 times v2 prime. So it looks like I have 3 minus 12 is going to be a negative 9 over here, negative 7 over on this side. So when I add it over, it looks like by doing my algebra, I get my final velocity for object number 2, and that's going to be negative 2 meters per second. If I want to do an original kinetic versus a final kinetic, my kinetic energy, original, is going to be 1/2 times my 1/2 kilogram object times 6 squared plus my 1/2 mass of 1 times 12 squared. It's a negative technically. With the squared, it'll take care of that negative and it won't matter. To determine my kinetic energy, I need to take the kinetic energy of each individual object before. So before I had 0.5 kilograms moving at 6 meters per second, gives me 9. I do the same thing for the second object, the negative 12. The negative disappears when I do a square, and I get 81. If I do the final kinetic energy, I do the same thing. I do 1/2 times the mass times the new velocity, which we have as, where are we at here? Which we have as 14 squared, plus we've got a 1/2 times a mass of 1 times 2 squared. Half times a half times 14 squared gives us 49. 1/2 of 4 gives us 2. So I add that and I get 51 joules compared to 81 joules. I can see that I have lost kinetic energy, which means by definition this collision is inelastic. And our final question, I have a bullet striking a block. They stick together. What's the original speed if I have a final speed? So one more initial equals final. I had the original bullet moving along with some mass and velocity. I have the two combined together afterward with the same final velocity because they're stuck together. So I have 0.05 times VO equals 0.05 plus 20 times the velocity is given to us as 2. So if I solve for VO, I get 802 meters per second.